to investigation 5-1 called chemical reactions. I have my apron on that I made in 6th grade. Yes, I did. But because I'm not quite sure how the chemical reactions are going to go. So I want to make sure that I'm properly covered. All right. Today, we are going to start, our main focus is chemical reactions, and we have 3 substances here. We have citric acid, which we've read about. We have baking soda. We also have calcium chloride. Calcium chloride. So, what we're going to start with is our focus question. What is the effect of mixing 2 substances with 50 milliliters of water?
It does nothing.
All right. So that's what our big focus is going to be on during our investigation. But let's go ahead and start with just some basics. Let's do a little review. What are the parts of a solution? What are the parts of a solution? Go ahead and raise your hand and shout.
It's like it dissolves.
No, what are the parts?
Oh, wow.
What are the parts of a solution?
The solute and solvent.
Okay, solute and solvent, right? Yes? All right. How can you make a solution? How do you make a solution?
You could put salt and water and stir it.
So salt and water together and stir it.
And also citric acid.
Or maybe citric acid. Okay.
Sugar.
So that's a solvent and a solute, right? Mixing together?
Mm-hmm.
Yes, Jose.
You can also make a solution by putting a solid material and a liquid material, and when the solid material dissolves, it's a solution.
Exactly. A solid and a liquid, and when it mixes completely, it becomes a solution, right? Okay, how do you know if a mixture is an actual solution?
Because you can't do solid.
What happens? How do you know if a mixture is actually a solution? Emmanuel.
It becomes the same anywhere.
So what is that called? Use some of our academic vocabulary.
It dissolves and you might see it like in let's say for example Kool-Aid.
Yeah.
See it, but water.
It becomes the same everywhere. It becomes the same everywhere, right?
Yeah.
So it dissolves in the solution and becomes transparent, or you can't see the difference between the solid and the liquid, right? All right. What does solubility refer to? What is solubility? We saw it yesterday in the video with the sugar, the Epsom salt, and the citric acid. Yes, Jose.
I'm pretty sure solubility is when you add too much of one solid and then it stops dissolving.
That is saturation.
Oh yeah.
That's saturation. When a liquid cannot take in any more of the solid, it becomes saturated. But what is solubility? No, it's not too much. That's saturation. Anybody else? No?
Is it close to saturation?
No.
Solutation. Too little.
It's not too little. Okay, Jose, what do you think?
The ability to dissolve.
Yes, it's the ability to dissolve completely in a liquid. And we saw yesterday that sugar, it takes 100 grams of sugar you can dissolve 100 grams of sugar in 50 milliliters of water.
So
that's a lot of sugar, right? Versus some of the Epsom salts. Remember, that was only 67 grams versus the sugar, which took 100 grams. So sugar is very soluble in water, correct?
It ate all the sugar.
It absorbs into it, right?
But the particles are still there.
All right, thank you. All right, so
the yeast.
yes, it becomes completely dissolved in it. All right, we're going to go ahead and start I have baking soda in this cup. I have calcium chloride in this cup. I have citric acid in this cup. So I'm going to now look to see if these become a solution with just the solid and the liquid, okay? So let's see if we can create
What?
I'm going to add 50 milliliters of water to the baking soda. Taylor, why don't you come up and stir this for us? Okay. Bradley, come up and stir the calcium chloride. And then
Watch, they both explode.
Megan, come on up and stir the citric acid
What is the logo?
and water. All right. So my question for you is, do you think these three substances
Are going to explode.
are will become a solution? Do you think the baking soda with just baking soda and water will become a solution?
No.
Which, what do we know about the word solution? A mixture that is blended so completely that it looks the same everywhere.
And a liquid.
So what about calcium chloride and citric acid? So I'm going to ask for votes. Baking soda?
Yes.
Yes. No. Citric acid and calcium chloride.
All of them, yes.
Okay. All right.
Take that out.
Daphne, do you think baking
Yes.
soda will become?
Yes.
Okay, do you know what? How about if you raise your hand if you think baking soda and water will become a solution?
This is sad.
1, 2, 3?
I know.
Just 3? Okay.
know.
How many people say no, baking soda and water will not? So you have to vote one way or another.
They're gonna merge.
So Johnny, I'm assuming that's a no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Which is interesting after everything we've studied. Citric acid. Do you think citric acid and water will become a
Yeah.
solution? Raise your hand.
Yeah.
No way.
Raise your hand.
Daphne's all yes.
What?
Yes.
Oh,
Okay, so we only have 5 people that think it's going to become a solution.
You've
go for
seen
the
it.
big-
Haven't you seen it in the video?
Okay, how many people think it's not going to be a solution?
Oh
1, 2, 3, 4,
Wow.
5, 6, 7, 8, 9, 10.
have a dumb costume.
10. All right. So you realize that's kind of what we've been studying this whole time. All right, calcium chloride. How many people think it's going to become a solution?
I'm sad too.
Yeah, I'm sad. I'm sad.
Wow. Okay.
Salt's gonna
I'm
be
the smartest.
And there must be one person that's going to think no.
Yeah.
All right.
Wait, no. There should be just
No,
one.
15. Oh.
Wait,
I guess we're going to have to go 2 here so it matches up.
Isn't there 19 kids in the
I know, but you 3 didn't vote. Okay.
Yeah, 16 plus 3 is 19. And this is
I know, but someone didn't obviously vote. Okay. All right. All right. Thank you very much.
Bye, Bradley.
Thank you.
Megan
All right.
Now it's
All right. Look at the citric acid and water.
Yes. I voted
Can
for
you
yes.
see
I'm sorry.
any citric acid left in the cup?
Yes. Anybody?
It's completely what? What's the word?
dissolved.
Just transparent and dissolved, right? Okay. Calcium chloride. Did it become a solution?
No.
Yes, it did. It became a
Wrong.
solution.
You can still kind of see it.
No, but it's not pulling at the bottom, and it became the definition of a solution. It is blended so completely that it looks the same everywhere, right? All right.
No.
baking soda.
No.
Yes.
Let me guess, Annie.
No.
It didn't.
Oh, yeah.
It didn't.
Yes.
Yes.
It did.
So
Whoever voted no for that.
a lot of people voted no.
I said,
Yeah, I
guys,
voted
when
no.
you bake, you have to probably
I think
bake
yes for everything.
baking
So-
soda
no,
with
you
something.
So when you think about it, the idea of baking soda, you put baking soda in food, right? You put baking soda when you bake cookies.
Exactly.
Baking
So,
soda or something,
If it
right?
doesn't become part of the solution,
And you can
Then-
part of the cookie.
it's what's going to happen to your cookies?
It's gonna dissolve.
It's gonna be burnt.
It's not going to necessarily burn, but it's not going to actually absorb and become part of the dough.
Exactly. Who
Okay.
voted no on that?
Okay,
Like mostly everybody.
Or who voted yes?
so
Daphne and
so
I
what
said
is
no.
the effect of mixing the baking soda and water? We made a what? Solution. What did we make by mixing calcium chloride and water?
Wait,
A solution. What did we make when we had citric acid and water? A solution.
What if you
Okay,
start with
so-
solution?
So, friends, we now know
It's a consensus.
it's a consensus. Yes. We now know that the citric acid, calcium chloride, and baking soda all form solutions when they are mixed with water.
Hello, what do you like to order today?
Okay.
from chicken nuggets.
Okay.
What if it was just like
Cool guy.
Okay. All right. So we now know that citric acid, calcium chloride, and baking soda all form solutions when they are mixed with water. But now I'm wondering, what is the effect of mixing two solutions together? Two mixtures together.
I think
Two solids together. All right. So that's what we're going to try to investigate right now. We know that individually they become a solution, but what happens when we start mixing them? What will happen? So, going back to our focus question, what is the effect of mixing two substances with 50 milliliters of water? What's going to happen? We know, again, individually they become solutions. But what happens when we put them together? So, you have a piece of paper that looks like this, right, that you have glued down. It says 1 spoon of calcium chloride, 1 spoon of baking soda, and 50 milliliters of water. So, on this sheet, as we add the water, you're going to write down what you observe and what's happening, okay? I'm actually going to call up 3 different people to come up here and stir
the mixture?
the mixtures. And I want you to be able to tell your classmates what exactly you're observing, okay? All right, here we go. Zoe, you can come up. Fatima, you can come up. Braylon, you can come up. Okay. All right, so we're going to go ahead and start. I have in cup 1, I have 1 5 milliliter scoop of calcium chloride, 1 5 milliliter scoop of baking soda. In cup 2, I have 1 scoop of 5 milliliters of calcium chloride, 1 5 milliliter scoop of citric acid. Then I have 1 5 milliliter scoop of baking soda and 1 5 milliliter scoop of citric acid. All right, here we go. Braylon, go ahead and take 1. Start stirring. Oh,
bubbly.
what's going on, Braylon?
It's bubbly.
Is it fizzing?
It's fizzing.
I don't know.
Oh my gosh, there's like steam out of it. It's like
How does it feel? What does it feel like, Braylon?
it feels like it's gonna explode. Exactly.
Is it? Okay, Fatima, take number 2.
Braylon, you can take that over.
It's literally sprinkling.
And Zoe, take number 3.
Yeah, come over here, Brady. You want to see?
What's going on? You can show the camera what's going on in your cup.
Same thing's happening to Zoe.
Okay, so on your sheet, your recording sheet right now, on cup 1, cup 2, cup 3, start writing down what you're seeing. You guys can walk around,
So cup 1 and 2.
and that way the kids can see. Okay, walk around. Be careful you don't trip.
I'll catch it. Yeah, I already wrote fizzy. And okay, so
Start writing down what you're observing. All right, so everyone had a chance to observe the cups inside the cups. On number 1, the baking soda, did it form a
Weird.
solution?
smells like milk.
Did it form a solution?
Yeah, no.
Yes.
What is the definition of a solution?
Yes.
A mixture that is so blended that it'll look the same everywhere.
Thank you.
Yes.
Is this a solution?
Yes.
Okay, so this is calcium chloride
tastes like
and baking soda. Now, what did you also notice what was going on in
it
cup
was
1?
fizzy, bubbly.
It was bubbling, it was fizzing, right?
Hear it.
It was fizzing, and after a certain time, it turned like milky color.
Okay, so it started off fizzing and then stopped fizzing and became just a milky color, right?
And smells like milk.
Okay, so, and then what about cup 2?
It looks like Sprite. Oh, wait.
It just
Wait,
looks like water.
what happened? What happened with cup 2? What was going on with calcium
There was
chloride
no
and
baking
citric
soda,
acid?
so it didn't do anything.
You can still see the baking soda on the bottom though.
There's no
There's no baking soda. This is calcium chloride and citric acid.
Yeah.
Did anything happen? Did this fizz?
Yes.
Did this do anything?
Yeah.
Fatima,
Yeah, it was bubbly.
Did anything? Did this fizz or do anything?
You can
No.
still
Did
see
you
a
just
little-
mix it and it just became transparent?
You can still see something on the bottom though.
Zoe went
Really,
Zoe
Jose?
did the same thing as mine.
All right.
And then it just
Now
turned
wait
into
a
Sprite.
minute. What about baking soda and citric acid?
It's Sprite.
Right.
Zoe, tell us what happened.
That one, it started turning white like Braylon, but then it just faded. The color.
So it
faded,
started turning white right away,
Yeah, and then the color faded.
and then the color faded.
Now it's colorless, and it looks like Sprite.
So it looks colorless. I mean, it became colorless or transparent. And what was it doing while you were stirring it, Zoe? What was going on?
It started fizzing up and bubbling up.
It started fizzing up. Yes, you're right. Yes, Bradley.
Is it if it's more dense, does it float or less dense?
Well, it depends. Like, because we didn't actually put a solid in it.
yeah.
I mean, we put 2 solids together,
Yeah.
right? Okay. So, what do you think caused the fizzing in cup 1 and cup 2? What could have been the catalyst?
Yeah.
Johnny,
Wait, you mean
Johnny.
1 and 3?
1 and 3.
I think. You think what?
You just said it.
Baking soda.
Yes, the baking soda
Yes.
could have been the catalyst to cause the bubbling, right?
Because in cup 2 there's no baking soda, and look at it, it's just clear. But in cup 1 and 3 there's bubbles and it's all like fizzy.
Yes, I love this. I love this. This is great. Jose.
I have a theory. Maybe baking soda made it be fizzy because isn't baking soda used to make bread grow?
Yes,
Um,
makes gas. So, wait a minute. Yes.
if you put baking soda in cup 2, I bet it would fizz up.
Yeah.
Oh, should we try that?
Yes.
Okay, now wait a minute.
Wait, we're gonna put them
Question.
all in one cup.
So, Bradley says he thinks the whole reason that cup 1 and 3 fizzed is because they both have baking soda in it.
Yes.
Cup 2 has no baking soda in it, right? So Bradley says, what if we put a scoop of baking soda in there? What would happen? Would it become a chemical reaction? So let me go ahead and
Oh my god.
Oh, buddy.
Oh
We made
There's
milk.
no. It's like sweat.
Yeah.
I don't mean.
Bradley's big brain.
Oh, okay.
We made milk.
okay. All right, so friends, the fizzing is produced by gas. And fizzing in a liquid is caused by gas. When calcium chloride and baking soda are mixed together with water, the gas carbon dioxide forms. The carbon dioxide is a new substance found in that form.
Can you mix
That's
all
more.
three?
All right, so what do you think about the white stuff in cup 1?
I think it's milky. It's a weird thing.
It didn't fizz.
It smells like
So calcium, oh, this one did fizz, yes.
all three of them now.
Well, all three
Well,
now. But
1 and 3.
calcium chloride mixed with baking soda fizzed, and baking soda and citric acid fizzed. Then calcium chloride with citric acid without the baking soda did not just mix together and became a solution. All right, so how could you find out if the white stuff at the bottom of cup 1 is undissolved baking soda or something else? What could we do?
Maybe a filter?
Maybe a filter.
No, not a filter.
Use
screen?
evaporation.
Maybe a screen.
I was gonna say screen.
Okay. What's that other thing that we were using?
Evaporation tray.
Yes, evaporation tray. All right.
Can you mix all three together?
So now,
We've already done that.
friends,
Number 2.
3, 2, 1. The white material is a new substance that formed when calcium chloride and baking soda mixed with water. When a new substance forms and settles out of a liquid, it is called a precipitate. So we now have a precipitate. We mixed two things together and it became something new. That's a chemical reaction. So, the production of gas and the formation of a precipitate are both changes. When two or more substances, like chemicals, are mixed together and a change occurs. We saw a change, right?
Yeah.
Yes or no?
Yes.
When the two substances or chemicals are mixed together and a change occurs, the change is the evidence that a chemical reaction has taken place. So right here, we have evidence that a chemical reaction has taken place. A reaction produces new substances called products with properties that are different from the properties of the original substances, which are called reactants. The reactants change into products during the chemical reaction. So, did a chemical change take place in cup 1? 3, 2, 1.
Yes.
All right, how do you know?
Because the same everywhere. It can't.
It changed into a new substance, right? Is this what we started with?
No.
No. Number 1, there was also a temperature change. This actually became warmer than
Really?
it started with.
Yeah, because it started like.
Why don't you drink it?
And gas formation and the result was a precipitate. Okay, did a chemical reaction take place in 2?
Not really.
Did we observe any change?
No. Yes, when you put in the baking soda.
Okay, but before that. No. No change was observed. Did a chemical reaction take place in 3?
Yes.
Well, no.
Yeah.
Yes.
It doesn't look the same.
No, it did have a chemical reaction because of the gas.
I know, but now it's
No, the carbon dioxide gas and the precipitate. So, yes, a gas formed. That was the precipitate. Okay? What are reactants and products? What is a reactant?
a reactant is when something reacts, and the product is like when two things mix together and they have solution. And
Okay.
not like a solution is not a solution. I mean a solution like
Okay, reactants, listen. Reactants are the starting substances.
okay.
They're the starting substances.
So it's like what trigger the chemical change. So the reactants are what trigger the chemical change.
Yes, so the reactants is what you start with, right? They trigger the change. Products are the new substances. So the products,
Like multiplication product.
are the new substances.
Like when
So you might start with 6 times 7, but you end up with 42, right? So the starting substances and the new substance, yes?
Yes.
Okay.
So maybe. So it's like a lion and a tiger.
Okay, no, stop. Okay, let's think generally about what might happen when you mix two substances with water. What are the possible effects? You could have 3 possible effects.
Fizzing, no change, and complete change.
Okay, so I like that. You could become a mixture.
A
Right.
solution or
A
a supersaturated.
Yes, a solution or a chemical reaction. So
or a supersaturated.
you could form a mixture, a solution, or a chemical reaction. Here are the 3 possibilities of mixing solutions together, mixing substances together. Okay?
Milk and cheese.
You can either have a mixture, a solution, or a chemical reaction. All right. So, what is the effect of mixing 2 substances with water?
They have a chemical reaction. Well, some have a chemical reaction, and some don't.
Does everything have a chemical reaction?
No.
Close, but no.
No. It could just form a mixture. It could form a solution, or it could form a chemical reaction, right? Okay. What I want you to take away from this is underneath your sheet, there are 2 questions. The questions are, which substances reacted to a form of gas? And number 2, which substances reacted to a form of a precipitate? So go back to what we did. Here are the descriptions. This is calcium chloride and baking soda. This was calcium chloride citric acid. And this is citric acid based baking soda. Go ahead and answer those 2 questions. So, you should be able to explain what happened in each cup. Go ahead and go. And then we'll check back. We'll debrief in 3 minutes. All right. So, based on what we just discussed, who can share out what conclusions they came to? Braylon.
For number 1, I said I think the gas reacted to cup 3.
Okay, the gas reacted in
cup 3.
In cup 3. What about cup 1?
Yeah,
That's what I said.
Okay,
that's what I said.
In cup 1 and in cup 3,
Yeah,
right?
that's right.
Okay. Any Anybody else except for the 3 people that constantly? Oh my god. Okay, go Zoe.
Who's the 3 people?
For number 2, I said that cup 3 and cup 1 reacted to form precipitate because when added, they both fizzed up, and then cup 2 reacted to form a gas.
Right on.
Well, there is, initially, the calcium chloride and citric acid only became a solution. It didn't have a precipitate. Okay,
Those
the only precipitates were in cup 1 and cup 3.
Yeah.
Because this one formed the gas, right? And this one formed a gas. But this one actually, the baking soda, it's interesting, actually will settle to the bottom, which is a mixture, right? When something settles. All right. You did a great job today. We're going to move on to the other little response sheet. The response sheet for investigation 4. And you're going to do that with a partner. All right. So, Bradley, what would you like to say?
I think that baking soda and the calcium chloride on number 1 is probably like the best to mix because it turned a whole different color. Even though like people are saying like it's the same, it's probably like a more reaction than number 3. I think
A better reaction, or
Yeah.
it formed more of a precipitate versus just the gas. Okay, excellent job. All right, you guys, excellent job. That is it for investigation 5-1, chemical reactions.